All right, here we go. We're doing number 21. What will be the equilibrium concentrations of each chemical species in the reaction above for a saturated solution of O-nitrophenol? So we want to use an ice chart and the results from the previous two questions, and we can assume that X is very small. So let's go ahead and see what we can do here. So it's going to want an ice chart. So let's set up an ice chart. Ice chart. Cool. And we solved for this in the last problem. We said it was going to be 0.015 molar. We solved for that in number, I think 20. Yeah. So we're going to start with this. We're not going to use this. It's a liquid. This is nothing, and this is nothing. So then we're going to change this. This is our x. This will be a plus x. This is a plus x. And then we're going to say our equilibrium is going to be 0.015 minus x. And we're going to say x, x. So then we can go ahead and say, or set up our Ka equals x, x over 0.015 minus x, like that. So if we're going to say that, we can simplify this and just say we have an x squared over here. And we know our Ka is 6.0 times 10 to the negative 8th. So now, they also told us that we can assume x is small. So we can get rid of that. So now what we're really doing is we're just doing math now. So if we want to go ahead and solve for x, we can go ahead and bring the x over. Let's rewrite this. 6.0 times 10 to the negative 8th times 0.015 equals x squared. So if I want to get rid of that squared, I can go ahead and square root all this. So I'm going to be left with an x equaling 3.0 times 10 to the negative 5th. So if I know that's my x, then I can go ahead and plug this in wherever I see x. I see x here and I see x here. So my H3O concentration and my whatever that is, I forgot what that is, they're both going to equal this. Okay? Now for this one, we have to go ahead and say 0.015 minus this. 3.0 times 10 to the negative 5th. And you know what? It's going to be really, really, really close because the number is really, really small. So let's go ahead and say it's going to be 3.0 times 10 to the negative 5th as well. So this is the concentration of everything right now. It's going to be concentration of this, H2O plus, and the product. All right, let's go to the next one.